There's nothing in the universe more important or mysterious than gravity. I'm Dr. Morgan Renberg, an astronomer at the Fort Worth Museum of Science and History. So, you could say that I've thought a lot about gravity over the years. Today, let's take a peek behind the curtain to see what's really going on. In physics, there are 4 fundamental forces that make everything in the universe work. The strong and weak nuclear forces help hold atoms together. Then we've got the electromagnetic force, and our friend, the gravitational force. Gravity literally holds together the galaxy, so at first blush, it seems like it must obviously be the strongest, right? But think about the last time you stuck a postcard on the fridge. The magnet that you used sticks because of the electromagnetic force. And that tiny little fridge magnet was able to withstand the gravity of the entire planet trying to pull it down. So, it kind of seems like gravity is pretty puny. And why doesn't the electromagnetic force stick the solar system together? It all has to do with balance. Electromagnetic force can be caused by protons, which have a positive charge, and electrons, which have a negative one. And once you get enough matter in the same place, it turns out that there's always basically the same number of protons and electrons. So they cancel each other out, leaving big objects like planets with pretty weak electromagnetic forces. But all matter creates gravity in the same way, so there's nothing that gets canceled out. That means that the more mass you add to an object, the more gravity it has. The first person to figure all this out was Isaac Newton, who discovered the law of universal gravitation. What's maybe most amazing is how incredibly simple it is. The law says that the force of gravity between 2 objects is equal to the mass of the first object times the mass of the second object, divided by the square of the distance between them. And then we multiply all of that by a special number called g, and add a negative sign to show that gravity pulls instead of pushing. Let's look at that piece by piece. The part with the masses tells us that gravity works both ways. The Earth isn't just pulling on us, we're also pulling back on Earth. The part with the distance tells us how gravity gets weaker as things move apart. If we doubled our distance from Earth, the pull of its gravity would be 4 times weaker. And if we're 10 times farther away, then we'd feel 100 times less gravity. That just leaves g, the gravitational constant. It tells us how to convert the masses and distances into our unit of force, which scientists today appropriately call the Newton. You can see the changing force of gravity in action when you look at the motions of the planets. As you move farther from the sun, every planet you pass moves more slowly than the last. That's because they get their energy of motion from the gravitational pull of the sun. And we just saw that the farther you are from the sun, the weaker its pull is. But what if we think bigger? The sun, like every star in the Milky Way, orbits the galaxy's center of mass. So you'd expect that, just like in our solar system, the farther you are from the center, the more slowly you'd be traveling. Yet when astronomer Vera Rubin actually measured the speed of stars orbiting in nearby galaxies, she found that that wasn't what happened. Instead, they all seemed to be traveling at about the same speed. That pointed the way to one of the 20th century's most important breakthroughs, the discovery of dark matter. Dark matter is invisible, yet it still exerts gravity just like the normal matter that we can see. Today, astronomers estimate that there are 5 times more dark matter in the universe than all of the ordinary matter we can see. As I'm sure you can imagine, this is just scratching the surface of what we know about gravity. In 1915, Albert Einstein developed his general theory of relativity, which remains our most accurate understanding of how gravity works. But unless you're planning on traveling to a black hole for your next vacation, Newton's law of universal gravitation is all you're ever going to need. Thanks so much for watching this episode of Discovery Lab Online. If you liked it, if you could take a moment and hit that subscribe button or give us a thumbs up, that'd be awesome. And if you've got a question or an idea for our next episode, leave it in the comments below or send it to questions@fwmsh.org. See you next time.